First off, thank you all for coming in. My name is Jack Heslin, as it says here on the screen, and this is a talk tonight about artificial intelligence. But before we get into that, a couple of things. I really want to include a shout out to Sandy and to the Lifestyles Committee. I actually approached Sandy last summer about doing this talk, and she thought it was an interesting idea. She invited me in to present to the Lifestyles Committee. We had some dialogue back and forth over a few weeks. By the fall, this date was available, and they said, yeah, let's do it. So thank you, Sandy, and thank you, Lifestyles Committee, for the green light here. The second thing I have to point out is a little bit of an apology. As I pulled together the content for this talk, I thought, I might want to use this content in other areas, so I decided to record it, which I never told Sandy. So I do apologize. There are cameras here. You should have been notified earlier. Our videographer tonight has been told in no uncertain terms not to capture any of you, okay? So that won't be a concern. So the talk tonight obviously is called The AI Conversation and Why This Matters. The goal here, the purpose of this talk, is not for you to walk out of here an hour from now thinking, hey, this is going to be great, or hey, this is going to be bad. Basically, I'm trying to share my belief with you, and I'm purposely not using the word concern, my belief that this needs to be managed, that there's a level of awareness here that is probably not seeped into the general public about first off, what is artificial intelligence? Is it really intelligent? And how are we going to manage this going forward? And that's why I very deliberately used the word conversation, the AI conversation, to be talking about this. So what are we going to talk about tonight? I know this looks like a lot. You'll be out of here by midnight, I promise. But I'm just going to make some quick comments here from the top about what got me thinking about spreading the word on this and having a conversation. A little bit about how I'm qualified and not qualified to give a talk on artificial intelligence. We'll talk a little bit about the framework for the talk. We're going to start with the framework, and we're going to come back to that framework at the end. And then we're going to get into it. What is artificial intelligence? How does it work? What does it do? We're going to talk about some of the questions that I think this brings up in society. We'll look at use cases. I skipped over one there. It does good things. It does some not so good things. And then we're going to hopefully have a little chat about what I hope will always be our advantage, what I hope will always be our sense of responsibility with this, the paradox between being a human being and what it means to have this technology. We'll come back to the framework, and then we'll wrap it up. I know it sounds like a lot. I'll talk fast. But and I should say at the beginning, this talk is broad. It's not deep. This is a real deep topic. So what we're trying to do here tonight is just give a sense of what all this could mean. And by the way, am I doing okay with the microphone? I'm a little new with the mic. Okay. Whoop, there we go. The beginning of thinking, why should we talk about this? I've been in sales for about 30 years, and most of my sales experience has been very tech-related. I was in the telecom industry for a long time. I was in the IT industry. I worked in 3D printing for several years. That was a great experience. But then, in the spring of 2021, I accepted a position as Vice President of Sales for a company developing a mobile app that, just using a regular smartphone, could take dimensions of tables and chairs and rooms. And that app had an AI component. It wasn't wholly dependent on it, but that was part of the technology. And that's part of why I accepted the position. It was a chance to learn something new. Almost from the very beginning, it was going badly. I didn't really care for the CEO, and I got the distinct impression the CEO didn't care for me. And a year later, I was out last spring. I'm not going to say the name of the company because, quite frankly, we're in litigation over me trying to get my severance payment. So I'm not going to get into that. But during that year that I was there, it gave me this little bit of an insight into this is different. This isn't just one more tech revolution or tech innovation. And I decided I wanted to keep my career and my interests around the technology, and that got me looking around. And as I was looking around, I came across this interview, which had a pretty big impact on me. I don't want to block anyone's screen here. At this point, Ginny Rometty was still the CEO at IBM, and she took IBM in a lot of directions, one of them being artificial intelligence. And this quote really caught my attention. She said to the fellow, "AI will change 100% of jobs." She could have said it will change a lot of jobs, many jobs. It'll have a big impact. 100%, that's a lot of jobs in all kinds of industries and sectors. So that kind of reinforced me to think, I want to know more about this. And what I did, hello, wake up. There we go. There we go. It's been fine through every practice run. Typically, when people give a talk about artificial intelligence, they have a background. They have a PhD in data science, or they have a PhD in some branch of mathematics, or they've done very, very high-level software development. I have none of that. So just will be very clear about that right up front here. Talk about arrogance. I'm going to get up here and talk about artificial intelligence with no credibility to do this. But yeah, right, yeah, no questions. But what I did do, because I want to start learning more about this, I found through the University of Texas what they call an AIML, Artificial Intelligence Machine Learning Program. And I did take some online classes that actually got me a little bit exposed to how the process works in the language. I can't write an AI application, let's be very clear about that. But I did get a good understanding of it. And then I took an online course through Wharton called AI for decision-making in business. So how AI could be used in human resources, how AI could be used by a chief financial officer. And along the way, I developed my own little library, which I brought tonight, those 3 books over there, basically talking about AI in terms of what it means for a society, what it means in the difficulty of understanding how it works, not just for people who don't have a background, even the people with the PhDs who build these things can have a hard time understanding the outputs that an AI model produces. And then also that last book, The Equality Machine, that woman has an interesting take. She thinks in time these AI models might help us realize some of our biases, some of our prejudices that we unconsciously over the generations have put into the way we work and run our companies and so forth. So that's my bio for talking about this. Now from there, hello. This has been working perfectly, by the way. The framework for the talk might seem a little anachronistic. When I think I was in high school when I read this biography of Harry Truman, and the truth is I don't remember 98% of the book. I really don't. But for whatever reason, this quote I never forgot. There's nothing new in the world except history you do not know. And maybe that stuck with me because I was a teenager. I never thought of history that way. But you know, you go through your life, you follow the news, and you realize there do seem to be things that reoccur. Events, whether they're terrible things like Ukraine, or whether it's the latest tech innovation, something faster, something quicker. Harry Truman, who apparently was a real student of history, said, "There's nothing new in the world except history you don't know." I never forgot that quote. Compare that to this book, and I brought my copy, The Age of AI, written by Henry Kissinger, Daniel Schmidt, who was the CEO at Alphabet that owns Google, and then Daniel Huttenlocher, who's a dean at MIT. Their quote is, "AI is an era unlike any that has come before." Well, these 2 statements are incompatible. One fellow saying everything just repeats and repeats, and these guys saying, this is new. We haven't been here before. So that's the framework for this talk. And we're going to come back to this slide at the end. So let's try to keep that in mind for the next little bit. So on that note, that wasn't supposed to happen. There we go. What is artificial intelligence? I thought it might be kind of fun. You've probably seen in the news the last several weeks about this ChatGPT. It's the online platform from OpenAI. You can put in an infinite number of questions on an infinite number of topics, and it'll come back with an answer. And I thought it might be kind of fun to ask AI how it defines itself for us here tonight. And I put that in, what is the definition of artificial intelligence? And oh my God, what a self-inflated answer. It goes on and on and on and on and on about tasks, about playing chess and a bunch of stuff. And I said, whoop. And I said, we're not doing this. Rather than read through this lengthy definition, maybe we just get right to, how does this work? And then once we understand how it works, you can decide for yourselves how you want to define it, okay? All artificial intelligence applications, there are no exceptions to this, have three components. You have your input layers, you have your hidden layers, and you have your outputs. It does not matter if we're talking about driverless cars or analyzing financial transactions for fraud or massive consumer spending patterns. Inputs, hidden layers, outputs. All of them work this way. Now, there we go. Inputs is what, in the lay public terminology, we would simply call data. And the data, and this is why AI is catching on so fast. This is why it's becoming such a big news topic. The data can be incredibly diverse. For example, let's say you are a large consumer products company, and you have millions of customers, and you have a lot of information about your customers. With artificial intelligence models, you can put in statistical equations, which we'll get to in a minute, that's about the hidden layers, that could very well show you patterns and trends in your customers' buying habits that you wouldn't have seen any other way. There's simply too much data. So this is sort of a tailor-made AI application. Consumer products company trying to learn more about its consumer base. Or, here's something, this is a medical application. These are MRI scans of looking for cancerous tissue. Millions of MRI scans could be uploaded to an AI model to see patterns in cancer detection that we've never been able to see before, possibly making it possible that we'll be able to detect cancer earlier. You could be an oncologist for decades. How many scans can you see? A few thousand? This could be a chance to look at millions and maybe find ways to detect cancer tissue earlier. Or, and this is a huge AI application, visual recognition. Now, in a way, this photo shouldn't be here because this is sort of an output photo, but visual recognition to be able to say, what's a car, what's a truck, what's a bus, obviously vitally important for driverless cars. But the thing to take away from this slide is these applications have nothing in common. Consumer spending patterns, medical research, visual recognition for driverless cars, but they're all inputs. And every one of them can be used by you can develop an AI application for. Now going from there, you get to the hidden layers. I call the hidden layers where the guts happen. In the hidden layers, you have the actual computations, which are based on all kinds of statistical equations. I'm not saying these equations. This is sort of rhetorical. I pulled these off the web. But the level of statistics that go into AI models is really sophisticated. This is where the PhD people come in about what sort of statistical models do you need to get your model to produce the output you're looking for. And those equations are represented, as you might guess, in computer code. This computer code is something called Python. It doesn't have to be Python. You can write AI applications in a number of different computer programs. Python is common because it's one of the easier languages to learn. It's very flexible. I got a small taste of it in my University of Texas classes. But this is where the guts happen. This is where all the computations take place. Now, skipping that definition, that wordy definition, why don't we think about AI tonight as inputs plus computations in the hidden layers equal outputs of a staggering variety. And I think this is what Ginny Rometty was talking about when she said 100% of jobs will be impacted by this. So we're going to look at a couple of use cases, one of them good, one of them not good, and then we'll get into some questions. So, There we go. I think the way I point this thing is what I have to remember. I don't have any medical background, so I need to be very careful how I explain this so I don't explain anything the wrong way. But apparently one of the issues developing in healthcare over many years now are strains of bacteria that are stronger, and they actually, our antibiotics are no longer effective against some of these stronger strains of bacteria. So what a team at MIT did is they said, hey, let's see if we can develop an artificial intelligence model to help us identify molecules that might be effective against these stronger strains of bacteria. And what they started with in their input layers, there we go, is something called the training data. So I said a few minutes ago, all AI models have inputs, hidden layers, outputs. The second thing all AI models have is training data and testing data. I'm not going to get into it really with any depth because that's a whole long explanation. But training data, to put it in very generic terms, is where we tell the model, where we tell AI, sort of like its criteria, what it has to base its outputs on, what's it looking for, and what does it judge that against? So MIT found 2,000 molecules, and they said, okay, these molecules, they assigned the atomic weight, the bonding characteristics, and their ability to fight bacteria. So that would have been their input. And then they said, they took a library of 61,000 molecules, now that they had their training data established, and put it in their hidden layers. And they said in those computations and those statistics and that computer code, they said, okay, we're looking for what could be effective again as an antibiotic, what does not look like any existing antibiotics, because remember, they're looking for something new. And of course, it has to be non-toxic. This is for a healthcare application. And they ran it through, and they came up with one molecule out of 61,000 that they thought would be effective to fight stronger strains of bacteria, and it's called Halicin. This is not on the market, just so you know. This is still in development. It's being tested, FDA approval, and so forth. And here's your trivia for the night, and I promise I'm not making this up. The reason they called it Halicin, it's named after Hal, the computer in 2001: A Space Odyssey. Here I'm thinking it's some great medical definition or something. No, it's after the computer Hal. Now, your big takeaway from this example is this project. The project may have taken several months, okay, to identify the 2,000 molecules, to set up the training data, to write the code that goes into those hidden layers. That took several months to put together. But when it came time to search the 61,000 molecules, that processing time was done in under 3 days. So that was really fast. You couldn't have, how many teams of researchers, how much time would they have needed to go through 61,000 molecules to identify one that could do what they needed? But here's where this is kind of a mind-expanding thing. Quite often, we look at technological innovations as something that made something simply faster or made something more accurate. This made it possible in the first place. I talked to some people I know who've done pharma research, and they said you probably could never even get funding to do a project like this, because how long would it take to search through 61,000 molecules, and how many researchers would you need, and so forth. So in this case, the AI made this medical research possible. It wouldn't have happened otherwise. And searching through 61,000 molecules in 3 days is not something any human team, no matter how big, could ever have done. So you might look at this and think, AI is great, to which I would say, not so fast. So let's look at a completely different example. There we go. The whole concept of artificial intelligence is not new. As a matter of fact, the very first concepts about it go back to the 1950s. By the 1990s, there was a software company, I think in Minnesota. They wanted to try to come up with sort of an AI model that would help predict recidivism rates for people who had either been arrested and they were being held for possible pretrial hearing, or they were already incarcerated. And they were trying to determine who's less of a risk to society to let them out on their own recognizance and who should be held onto. Now, some of this data you're going to see here is several years old. I believe this issue's been fixed, but it was in place for many years, and it had real issues with it that weren't checked for way too long. So here, the inputs were things like, well, what's the person been arrested for? Do they have prior offenses? Do they have a job? Do they have a history of drug abuse, domestic abuse? What is their education level? And what proved to be an unfair variable was, where do they live? Where did they grow up? What's their neighborhood? Now, unlike with the Hallison example, these are private companies, and they didn't really reveal how their internal machinations work. They said, this is our secret sauce. You know, we're a software company. We don't show the public how our product does what it does. But it was deployed throughout the 90s and early 2000s, and a lot of states started to adopt it in their parole hearings and sentencing and so forth. The point of the software was to predictions for recidivism, as I said. And the predictions for recidivism had a lot to do with who was going to be eligible for parole, who was a higher risk, who was a lower risk. So, okay, and by the way, this comes out of the alignment problem book. My copy is right over there. So here's what happened, and this went on for years. The fellow on the left, you see in the red there below his name in his picture, he's a low risk. He got a 3. The woman on the right is really not a woman. She was 18 years old. She's a high risk. She was an 8. Now, the fellow on the left, Vernon Prater, this is his background. He's 41 years old when he got arrested. He had 2 armed robbery prior offenses. In attempted armed robbery, this is past. This has already happened. And he gets into the software, and he's low risk. So he's low risk, so he's okay for recidivism. He's not going to go back into society and commit a crime, except it's exactly what he did. He was released on his own recognizance, and he went out and he robbed a Home Depot, I think, for tried to rob a Home Depot for several $1,000s. Why was he low risk? Now, this girl was 18 years old. She and a friend were in a rush to get someplace. They saw some children's bicycles. They grabbed on the bicycles. This was theft. They were stealing them. They took off on the bikes, which apparently were too small for them to ride. They dropped the bikes. They ran away. In the meantime, someone had saw them and called the police. Now, she had some prior juvenile misdemeanors, but nothing violent, no armed robbery. And she got rated a high risk. She was an 8. And she had no subsequent offenses. So in this case, this model, this software model, had it exactly backwards. It's saying that the guy with the armed robbery offenses, he's okay. He's a low risk. The girl who stole about $60 or $70 of a children's bicycle, she was high risk. So the model had it exactly backwards. And this is not unique. Here's another example. A fellow on the left, James Ravelli, 54 years old. Prior offenses include domestic violence, grand theft, petty theft, drug trafficking. Somehow he was rated a low risk. And if he's low risk, you can let him back out. And once again, this guy commits another crime. The fellow on the right, and I really did try to find his age. I couldn't, but he looks awfully young. He had a prior petty theft offense, got rated a medium risk, which is higher, but he had no subsequent offenses. So once again, the software is getting it exactly backwards. And you think, well, how does that happen exactly? And this is dated information. Nothing here is after May 2016. I believe the software has been corrected. Now, I could go through many cases of this. I'm not going to. But the point is, this wasn't unique. The fellows on the left here had drug possession, domestic violence, battery. I think there's DUIs at the top. The people on the right, you can see medium risk or high risk, and it's blatantly obvious that the ones who were considered low risk were white males, and the ones who were considered medium or high risk were black or African American. So you might say, well, that's all prejudice, that's racism. Well, I'm not saying it isn't. The question is, how did this happen? And this is the most important thing I'd like you to take out of this talk tonight. How many here people think the artificial intelligence model made a mistake? How many of you think the artificial intelligence model made a mistake? Oh, several of you did. Yeah, all of you are wrong. It didn't make a mistake. It's about, what did you say, ma'am? It's about the inputs. Remember I showed those inputs about what their background is and so forth? One of the things that included there was neighborhood. So if you were living in a neighborhood with gangs or drugs, even if you never were associated with that, the system tagged you with it because you're in a high crime neighborhood, therefore you're a risk. It was completely unfair. And you have to, I forget the woman's name, but about 10, 11 years ago, there was a woman who said, is anybody checking these? Is anybody looking at this? And apparently nobody really had. And she was the one who kicked it off to say, okay, this model isn't right. Now, I believe they've tweaked it and they've tweaked it and they've made it better. But the takeaway here is AI, and it doesn't matter what it is, AI cannot do anything over and above the data we give it. And that's our responsibility. So when you see these news headlines saying, oh my God, AI is coming, that's not the concern. The concern is what are we going to do with it and how aware are we going to be with what we give it for information? So Hallison was a great example. This is a bad example. I could have done a whole talk on examples, good and bad, but I just wanted to give you a pro and a con here. And let's move on to new questions. For many years, I have been reading The Economist. It is far and away my favorite thing to read. And last June, my copy of it is right there, they did an article called AI's New Frontier on something called foundational models. And what that means, one of the limitations of artificial intelligence models was they had no flexibility. In other words, you could build an AI model to play chess, unbeatable chess. Great chess player. It couldn't play tic-tac-toe. You'd have to build a whole new AI model to play tic-tac-toe. But one of the breakthroughs in the technology has been these foundational models where you kind of lay the building blocks and then you can build different applications off the foundational model. So that was a real breakthrough. So that's what this article is about. And The Economist and the writer of this article decided to do something kind of clever. They took 100 of this fellow's previous articles and they uploaded them to the hidden layers. And then they took this article that he had written but hadn't finished. It needed a concluding paragraph, and they uploaded it to this particular AI model. And this would be called like a language model, not a mathematical one, not a language model. So here the hidden layers would have been, there we go, would have been searching for the writing style. How does this fellow use nouns, pronouns, adjectives, adverbs, and so on? It's got 100 articles to scan through, and it's got the article he's written for this piece, but not finished. And then in the hidden layers, it asks the question, this is so fascinating. He's using a foundational AI model, and then asks that, he's writing about foundational AI models, and then asks it, what good are you? What is the value of a foundational AI model? And this I will read. They, meaning foundational models, they take away the heavy lifting, figuring out what a story is about. But sometimes a good story needs more than just a foundational model. It needs something to kick off the writing process, something that sparks the journalist's imagination and offers a clear path towards writing. The best models, then, are not just predictive, but inspirational. If you didn't know an artificial intelligence model wrote that, how many of you would have guessed? Yeah, nobody would have guessed. When I first read this, what jumped out at me were the words imagination and inspirational. I read this and I thought, no, wait a minute. To me, those are very human words. We use words like imagination and inspiration. How could a computer do that? But then I remembered, it scanned 100 of this fellow's articles. If he's using words like that or synonyms to those in his articles, it's going to pick up on it. Now this for thousands of years, we've been the writers. We're the ones who write. And now there's sort of this new paradigm about how much writing do we do and how much do we rely, potentially, our kids, our grandkids, if you have to do a book report on Abraham Lincoln, what's the work division here? So my question is this a good thing? I don't know. I'm not saying it's a good thing. I'm not saying it's not. I'm fully in favor of the debate. I also think we're going to spend a lot of time in the years to come figuring this out. So, but I will tell you, when I read that, it was like, wait a minute, that's good writing. That's fluid writing. And a machine did do it. Let's shift gears. Wow. There we go. There it is. What building is this? Come on. Yeah, it's the clubhouse. That's exactly right. This is the clubhouse. And what style of painting is that?
Van Gogh.
That's Van Gogh. That's exactly right. Now, here's what's kind of wacky about this. I did this. I did it. Now, not only can I not paint like Van Gogh, I can't paint. I'm not an artist. So how did I do this? Well, about a month ago, I was behind the clubhouse at about 6 a.m., and I took this picture with my phone. Just a regular old iPhone 14 is what I have. No special camera, no special software. I just took the picture, and then I went to a website called Night Cafe, nightcafe.studio, if any of you are curious. And I uploaded the image. Now, in this website, you can do all kinds of things to a picture. You can change the coloring, the filters, you can add things to an image. I think you can even delete things. But one of the features it has is the ability to, I think it has like half a dozen or so different artists' styles. And it says one of those styles is Van Gogh. So I said, all right, what the heck? And I did this all like the same day. I mean, it wasn't like a big deal. And I said, okay, pick the Van Gogh style. And it rendered it. There it is. The total rendering time was about 2 to 3 minutes. And I don't think I paid for it. I don't think I did. I don't quite remember. But the point is, it was that easy. I took the picture. I could take a picture of any of you. I could upload it, and in 10 minutes, we'd have a portrait of all of you in the Van Gogh style. It wouldn't take any time at all. But you know what? I like Van Gogh, but I also like Picasso. And that took another 2 to 3 minutes. Now, this couldn't be simpler, okay? But this is about new questions. So here's the question. Let's say that middle painting there, let's say instead of, it's not Picasso, it's one of you here tonight. One of you is the artist. And you say, that style, I know that style, that's me, that's my style. And I say, oh yeah, you're right, you're absolutely right. I looked at 100 of your paintings, took pictures of all of them, uploaded them to this website, and so we created your style, recreated your style, and then I took other pictures and I started to sell prints of pictures I've taken but in your style. And you're going to say, whoa, 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 that's my style. I should get royalties off of that. And I'll say, you didn't paint it. But so you know you're not getting royalties. And you're going to say, that's my style. Now, I don't have any legal background, but I think it's a safe bet that in the coming years, we're going to see some court cases about copyrights, about trademarks, about patents, where there's going to be a lot of debate about the division of work. What do you get credit for and what you don't? Even though I'd been reading about this for a while, I was still surprised at how easy it was to do it. And it was really simple. So, moving on. How many here have heard of the Chinese game Go? Okay, not many. There we go, a couple in the back. Go has been played in China for several thousand years. It's a two-person board game, 19 lines horizontal, 19 vertical, and then each player gets 181 stones. You place the stones at an intersection where the lines cross, and the goal is to align your stones in such a way that captures more territory than your opponent. I don't really know anything about Go, but when you read about it, they say it's actually more complicated than chess. The permutations go into the trillions of all the different ways people can arrange the stones. Now, The top of this slide says outcomes we don't understand but are correct. And what I mean by that is this fellow, Lee Sedol, is a South Korean Go player. He's retired now. But during his career, he won many international titles, and he is part of that debate about who is the best Go player in history. So in the world of Go, he's like a Bobby Fischer. He's like a Boris Spassky. He was that elite level, by some to be said to be unbeatable. So a company called DeepMind in England came up with their AI model just to play Go. And the reason they did it is because this game is apparently really complicated. And the way they taught their AI model to play Go is they did upload standard Go strategies, not new, but they did something else. That third bullet point there, they had the model play itself. And it played itself millions of times. Some people say it played itself tens of millions of times. Someone else said, no, it was 100 million times. The company isn't saying, but it was many millions where it played itself back and forth over several weeks, millions and millions of times. And in so doing, it came up with strategies no human being could ever think of. So what happened? So they set up the big event. I'm going to get out of your way here. And if you go to YouTube and type in AlphaGo, you can see the whole documentary. It's all right there. This is a screenshot I took. Now, that red circle over that black stone there with the A on it, that was an AlphaGo move. And the guys in the lower left, they're the commentators, just like commentators in baseball or football. These guys are talking about the match, and they're saying, that move's not right. Why would it make that move? There's something wrong with that move. They don't get it. And then Lee Sedol, this is his reaction. He sees the move, this world champion, elite player, and he doesn't get it. I'm not trying to put up an unflattering picture. I'm trying to communicate this master Go player is like, what kind of move is that? So everyone's thinking that AlphaGo made a mistake. Well, they played 5 games, and AlphaGo won 4 of them. And it won 4 of them using strategies no human being had ever thought of. It could come up with the strategies because it played itself millions and millions of times. And I really want to give a shout out to Lee Sedol, because he is apparently the only human being to ever have beaten AlphaGo at least once. He does have his one victory. Now, let's talk about all of you. Okay, AI, it's fast, it does cool things. How many of you have mutual funds? Yeah, quite a bit. How many of you have pension funds, IRAs? Yeah. So this was in Forbes last summer. Why an AI portfolio is better than a traditional fund manager. This was in the Wall Street Journal. The artificial intelligent investor AI funds beckon. But just to be on the flip side, just to be devil's advocate here, I did find, as I was pulling this together, as recently as last September, a newsletter called The Evidence-Based Investor saying it's done a comparison of traditionally managed funds and AI, I'm not going to say AI managed, but influenced funds. And as of today, or at least last September, they couldn't find a big difference in the return on investment. The AI funds are doing a little bit better, but that mostly had to do with lower transaction costs, less buying and selling of stocks. But in terms of the actual assets, there wasn't a big difference yet. But this is in its infancy. It's going to happen. So here's the real pain in the butt about this thing. It's entirely possible that AI-managed funds are going to start making superior investment recommendations we don't understand. And we know that AI can do things we don't understand because we saw it in the game of Go. There's also AI models that play chess, and they win chess games with strategies we don't understand. So I think it's entirely possible you could call your fund manager one day in the future and say, why are you buying this stock and why are you selling that one? And your fund manager will say, I don't know. That's what the AI model says to do. The flip side is this. inferior investment recommendations we don't recognize, and we know AI models can get it wrong because it got it wrong with the parole example. Now these are based on human inputs, but the point is, this technology, we've built this thing, we built the computer chips, we wrote the software, we invented the statistical equations, we did it all, but we've made a tool that can actually do things that we don't always understand the outputs, and probably don't yet, as a society, as a culture, understand the power, the importance of our inputs in determining its outputs. So going from your investments and your portfolio, let's talk about your country. I was very curious. I started doing a little digging on this. Are AI models being used at all currently in monetary or fiscal policy? And a bunch of examples came up. Bank of Norway been using machine learning algorithms to analyze economic data for monetary policy. Canada exploring AI models to analyze economic data and possibly make policy decisions. UK government using an AI model to look for fraud and tax evasion to maybe increase tax revenue. I did specifically look for the United States doing this. DC is just a couple hours from here, and I couldn't find any examples yet. But I gotta believe people are talking about it. And my guess, and this is just a guess, is that there'll probably be some policy think tank that says, you know what? Let's look at all the Fed decisions over the past 20 years, or let's look at all of our fiscal policy decisions over the past 20 years, and let's build our own AI model based on all that input data and see how our AI model would have done. And it would probably do badly at first, but it can be tweaked to get more accurate, more accurate, more accurate. This is probably going to happen. So from your own personal investments to your government's monetary and fiscal policy, this will almost certainly play a role. But let's get to a bigger scenario that's kind of scary. And I'm not trying to scare anyone. And this comes right out of the book of The Age of AI. I don't have a military background, but I think I'm on safe ground saying that when countries go to war, one of the things you do to avoid the war is to say, okay, who has more tanks, more ships, more soldiers, who has fewer? And the smaller country says, no, we're not going to go to war with them. We don't have their size military. But we've seen now that AI models can be extremely sophisticated. What if the smaller nation has a superior military AI? And this is not something you can float a Chinese weather balloon over and say, how's their AI look? There's no way to espionage that. And what if they start to deploy their forces in strategies that have never been seen before, like we saw with Go, like what happened with chess, like what will probably happen with investment strategies? If that were to take place, how long would it take military commanders whose first reaction would probably be, they don't know what they're doing, they're making a mistake. And then they would realize, wait a minute, there's something effective going on here. How long would it take them to realize that? How long would it take them to react? And since all those military commanders would have some history, what if the military AI predicted their reactions? And what if by the time it was all over, it would be too late anyway? Now, I want to emphasize, this is a hypothetical. No one's saying this is happening today. No one's saying it's going to happen in the next 5 or 10 years. But Henry Kissinger brought it up. So I thought it was a good thing to share. The point is, and this gets back to Ginny Rometty's comment, that everything will be impacted by this technology in ways that we haven't even really started to think about yet in terms of our own responsibility in using it. And that brings us to what I hope, it's my opinion, and I'm open to every opinion that disagrees with me. I think we should discuss this. What I hope will always be the human advantage. I think one of the great things about us, and maybe we should appreciate this about us more than we do, we have the capacity for doubt. We have something called intuition. We have the ability to question facts. And what I think might be most important, we have the ability to take initiative. So Pete here and I are working on a project. Pete's waiting for some information from me. I give him the information, he reads it, and he says, Jack, where did you get this from? Something here doesn't seem right. That's a wonderfully human quality that we probably don't give ourselves enough credit for. And I say, well, here's my research on it. Now, there's an image I saw online that I completely disagreed with. This is kind of the contemplative AI, the thinking AI. Pardon me for saying it this way, but that's crap. AI has no contemplative abilities whatsoever. It has no ability for doubt. It has no ability for intuition. And it would never say, like those parole predictions, those recidivism predictions, we think this person is this level of risk. We think, no, it comes back with certainty. It doesn't have the ability to question itself. And that is where I think news stories today really miss the mark. AI can do this, AI can do that. AI cannot do anything over and above the inputs we give it. And it comes back with certainty. And I think we always have to remember that. I gave an example to somebody once, and they said, geez, Jack, that really crystallized it. It's absolutely possible to create an AI model for driverless cars that would run every red light and stop at every green light, because that's what it was programmed to do. It doesn't know it's breaking the law. It wouldn't know that it's causing possible accidents. And that's where I think we have to realize that our responsibility for this technology is enormous. And that leads to what I would call the human AI paradox. Paradox is one of my favorite words. What's a paradox before I put it up? Anybody want to just offer that? A true paradox? Sir? Yeah, a contradiction. A paradox is, here's two events that appear to be contradictory and illogical. They don't make sense, so it must be wrong. Only when you drill down on it, it actually turns out a paradox is true. It's a very powerful thing, a paradox. So I think what's going to happen, and that parole example that parole use case is a good example of this, is that as we teach AI models to be more like us, as we try to convey to it the outcomes that are in line with our values as a society, our morals, our ethics, safety, public safety, I think what we're going to find is AI is going to start teaching us more about ourselves. And I think that might be kind of a rocky journey for years to come. And I'm not trying to pick on the company with the parole software, but they were very defensive. They said, our software gets it right, like 70% of the time. I'm like, so 30% of the time you got it wrong. You know, you shouldn't be bragging about this. But there's a lot of complication that goes into our looking at the mirror, and now we have this incredible tool that might force us to look in the mirror in ways that maybe we haven't had to do before. So, the framework. We started here at the beginning. With a true student of history who got to be the President of the United States, saying there's nothing new in the world except history you don't know. And then some other very worldly fellows, all very successful, saying, this is new. We've never faced this before. Well, I'm open to every opinion that disagrees with mine, because I think it's important to have this debate and this conversation. But with all due respect to our 33rd president, I do think this is a seminal moment, quite possibly in history. You can go generations, you can go a couple centuries without a true seminal moment. But we've created a technology built on our computers that we designed, our computer chips, the software we wrote, the statistical equations that brilliant human minds came up with, and we built a tool that can have outputs we don't fully understand, and some of those outputs will be superior judgment to ours, and some of those outputs will be inferior judgments to ours, and how do we tell the difference? We're going to be figuring out how to work with this for, I would say, years to come. So let's wrap it up. Artificial intelligence isn't just one more thing that does stuff faster or more efficiently. I think what we're going to see in the years to come, that this really becomes part of the fabric of our lives. And that's why I put question marks into all those overlapping jigsaw pieces there. Because I think we're going to be figuring this out, the human AI relationship And it is a relationship. Have no mistake about that. This isn't just like, you don't have a relationship really with your car or even your phone, no matter how much you might like using them. This is going to be part of your day-to-day life. And I think we're going to be figuring that out for years to come. So on that note, thank you. Thank you. I like the phrase, the AI conversation so much, I grabbed the domain name. So if anybody wants to email me, just thoughts, questions, comments, let's talk at theaiconversation.com.